We will see how some very simple and basic observations about the human learning process can be translated into machine learning. We all know that learning is a very complex task, and doing it properly requires patience, dedication, and skill. There are many ways to learn something. At school, a lazy student can learn a lesson by heart. A better student may try to understand how things work. This is related to the ability to generalize what has been learned to a larger extent. Moreover, teaching at its basic level is an iteration of training and validation phases. And finally, a test will assess the final proficiency of the learner. Let's see how this works in the world of machine learning. Many learning tasks, both at school and in computers, can be viewed as supervised classification problems, where the teacher provides a set of labeled samples and the learner must learn to correctly label new samples. In our example, the teacher, that is we, will train the learner, that is the computer, to tell ducks from geese. To this purpose, the teacher shows pictures of ducks and geese to the learner and tells what they are. If the learner is not very skilled, he might just want to learn by heart. He'll just take all pictures and memorize them, keeping ducks separate from geese. Apparently, this works well, at least as long as the learner is tested on the same images it was trained upon. But when presented with a new image, it won't know what to answer. This is why learning by heart is discouraged and can lead to intense frustration. In fact, learning by heart is not different from memorizing a list of names and phone numbers. This is what databases are made for, and they are very good at it. But you cannot ask a database for an item of information that it doesn't have in store. A database cannot generalize its knowledge to account for new cases. A clever learner will rather try to find what details in the image are more important. It builds a model, a sort of idealized duck and goose, and tries to keep this information general enough to be able to apply it also in new cases. In this case, the shape of the bird's bill and neck is a very important detail to look at, and our learner can exploit this to obtain a much better performance, even on cases that were not considered during the training phase. Is that all? Just take a bunch of images of ducks and geese and feed them to the computer? No, it's not that simple. Well, we, the teacher, must take care of guiding the learner. First of all, let's divide the samples in 3 sets, possibly at random. The first, larger set will be used for the actual teaching or training. The second, smaller set will be used from time to time to validate the model built by the learner, that is, to check the learner's progress. Finally, we keep a third set apart for a final test. As in real life, it is important to keep the 3 sets separate. We want to test the learner's understanding by submitting to it a problem that he has not seen before. The process starts with the teacher presenting some training samples to the learner, each labeled with its name, goose or duck. By analyzing these samples, the learner builds a model. As we can see, in this case, the model is not very likely to succeed. Now we move to a validation phase to check if the model built by the learner is accurate enough, by submitting the validation set. If the learner is not accurate, the model has possibly captured the wrong details from the training samples, as in this case. Therefore, the training process is repeated, maybe with some other training samples, and a new validation is performed. The process iterates until the response of the learner is accurate enough. At this point, the training process is complete, and we can use the third set of samples, the test set, to assess the accuracy of the trained learner on a set of images that it has never seen before. Measuring the accuracy of a learner can be tricky, and this will be covered in another video. To wrap up our short discussion, the goal of machine learning is to build a model that generalizes to new cases. Machine learning is very powerful, but requires a strict method where the learner is repeatedly trained and validated. Finally, to be on the safe side and enter the machine learning paradise, please set aside a few examples and only use them at the very end for a final test. Thank you for listening. You will find much more details in the book.